In number 6, we have the graph of f. It asks us to find the value of the integral from -6 to 0 of f of x dx. So again, make sure you're starting at -6 and ending at 0. This is where we want to stop. So make sure you're paying attention to those bounds. I'm not doing like all the area under this graph. So again, let's pay attention to what part of our graph is positive versus what part of our graph is negative. So this area up here will be positive. This chunk below will be negative. So when I'm finding the area above, I will add, below I will subtract. So for the triangle above, remember area of a triangle is half base times height. My base is 4 from -6 to -2, and my height is 3. Now I'm going to subtract my second triangle, 1/2. My base is 2 from -2 to 0. My height is 3. Make sure you're not using -3 here. You could think of the negative on the 3 being this minus, that's why we're subtracting. But when we're finding the area, we're going to use the positive distance 3 there. So the area up above was 6 minus the area below, which was 3. So this was 6, this was 3. So that total area is 3. In number 7, we're asked to find the integral from -7 to 8 of f of x dx. So we are going to essentially find all the area under the section of the curve that we're given. Let's pay attention to which part of our graph is negative and positive. So this area right here, this would be a triangle, is below. This other triangle is below as well, so those areas will be negative. The semicircle is going to be positive area. So for our first triangle, we have a base of 7, a height of 4, and so we have -1/2 times 7 times 4 plus, for a semicircle, remember our area of a semicircle is of a circle is pi r squared, so we're going to do 1/2 pi r squared. But keep in mind that our radius here is not 4, that's the diameter. So I have to look at 1/2 of the diameter there to get my radius. My radius is 2. And then I'm also going to subtract the area of this last triangle. The base there is 4, the height is 2. So -1/2 times 4 times 2. So this will give me -14 plus 1/2 of pi times 4, that would be 2 pi, minus 4. So I have 2 pi minus 18 for my area there. In number 8, we want to find the area from -5 to 2 of f of x dx. And so let's start at -5. This chunk up to -3, that triangle is going to be negative. And then we're going up to +2, and so that's this piece here, then following this circle up to 2. And so for this part, we will have to split it into a triangle and then this curvy bit right here. Now what we want to pay attention to is that this piece, this shape, even though I see a semicircle on my graph, that's not what the area of this shape is. If I want to find that area, I will have to do a rectangle and then minus a quarter circle, and that would give me this area that's left over. So pay attention, that's different than the last graph where the radius or diameter was on the x-axis. When your radius or diameter is not on the x-axis, it's not just going to be that area of a circle. All right, so our triangle below was, so remember it's negative because it's below, 1/2. My base is 2. My height is 8. Plus this triangle here from -3 to -2. So 1/2 times my base is 1. My height of that triangle is 4. Plus, now we'll do this rectangle bit. So my rectangle here has a base of 4 and a height of 4. So 4 times 4 minus, the area of my quarter circle. So quarter circle would be 1/4 pi r squared. The radius of this circle is 2. So I can see that the radius of that semicircle is 2. Now let's go ahead and simplify. Oh, sorry, I don't know what happened to my negative there. So this is -8 plus 2 plus 16 from the 4 times 4 minus, sorry, I don't know why I put a 2 here, but we said the radius was 4. Silly mistake. Radius is 4. I see the radius of 4 there. So this is minus of 4 pi. And so that gives me 10 minus 4 pi for my integral.